A very important circle for mathematics. We can highlight its definition. This is the unit circle. A circle whose center is at 0, 0 and has a radius of 1. And that's why it's called a unit circle, because its radius is 1 unit. And now we're going to see the connection between circles and trigonometry, and how the two bounce back and forth and can explain some things like the cast rule that we've seen before. Now, you take any point on the unit circle, and they've chosen a point here in quadrant 1. The radius would be 1, and if you went back to the nearest x-axis, because reference angles are important, if you go back to the nearest x-axis, you would make a right-angled triangle. And in this right-angled triangle, if this point was x comma y, the length would be x, the height would be y, and of course the radius would be 1. And from this, you could do sine, cosine, tan. If we called this angle, well, this is our reference angle, but because it's in quadrant 1, it's also our actual angle in standard position. From this triangle, using previous math, sine is always the opposite side divided by the hypotenuse. In this case, our opposite side would be y, and our hypotenuse is 1, so this is just y. And on that same triangle, if I did cos, the adjacent side is x, the hypotenuse is 1, so this is just x. Which means if we have a point on the unit circle, instead of calling that point x comma y, we can talk about that point only with theta. We can say the x coordinate will be cos of theta, and the y coordinate will be sine of theta. And for this unit, there are 3 big ideas. You can either write this on 469 if you have space, or there's space at the bottom of 470. Big idea number 1. Points on the unit circle are cos theta, comma, sine theta. Which is kind of interesting. We can explain some of the cast rule from this. For example, and we'll just explain the cast rule for sine and for cosine. We'll do tangent later. Pick a point if it's in quadrant 1. Is your x coordinate positive? Is your y coordinate positive? Yes. So in quadrant 1, both sine and cosine are positive. If I pick a point in quadrant 2, is your x coordinate positive? No. Cos is now negative in quadrant 2, because cos is your x coordinate. What about your y coordinate? Is it positive? Yes. Sine is positive in quadrant 2. If you go to quadrant 3, move the dot. There it is. Both negative. According to your cast rule, are sine and cosine both negative in quadrant 3? And what about in quadrant 4? Your x would be positive and your y would be negative. And so your cast rule is sort of explained. Next, in this box, it tells you the equation of a circle, of the unit circle, is x squared plus y squared equals 1 squared, which is just 1. The equation of a circle is just Pythagorean theorem. Do you see how it makes a triangle? Can you see that no matter where you put, you get an x coordinate and a y coordinate, and the radius would always be 1? And if you did a squared plus b squared equals c squared, you would get x squared plus y squared equals 1 squared, which is 1. Which leads to the second big idea. If x is cos and y is sine, then apparently cos of theta and I square it plus sine of theta and I square it should equal 1. And this is one of your first formulas on your formula sheet, which I haven't given you yet. On your formula sheet, the formula likes to write, because you're adding, doesn't matter the order, your formula writes sine first, and mathematicians don't like brackets. So they're like, well, how can we get rid of brackets here? We could just get rid of them, but then we have an issue. If I just get rid of them and have it squared, how do I know the whole thing is squared and not just the angle? So they're like, we will make up our own rules. I love it when mathematicians like, tired of something? Let's make up our own rules. If we want the whole thing squared, but we don't feel like writing brackets, we'll put the squared in between. If we put the squared at the end, then you know I just want to square theta. If I put it in between, you know I want to square the whole thing. Calculators still need brackets around it to square the whole thing. Okay? All right, we are going to do some mental math. Let's pick an angle that everybody has memorized, 23 degrees. Okay? I would like you in your head, without a calculator, to do sine of 23 degrees. You only need to know in your head 11 decimal places should be good. Okay? Now take that number and square it. Again, 11 decimal places should be good. Keep that number in your memory off to the side. Now we're going to do some more mental math. We're going to do 23 degrees still. This time we'll do cos. Cos of 23 degrees. Again, 11 decimal places should be good. Square it. Take that answer and add it with the answer you had before. What do you get? Amazing mental 1. That's amazing mental math. Like let's, holy smokes, here we go. Sine of 20, if we did it on our calculator, 1, 2, 3, only 10 digits. What was the next digit?
A digit.
7.
Amazing. Amazing mental math. 7. Perfect. Then square that. Also 11 digits. Then did cos of 23. Again, 10 digits. What's the number after that one?
2.
Wow. Amazing. And then squared that. And if we took our first answer right there and added it, you're just double checking your mental math here, added it to our second answer. 1. Amazing. Second major big idea of this unit. And it doesn't matter which angle, as long as the angle's the same. Sine squared of theta plus cos squared of theta will always equal 1. Next big idea comes from, well, which one didn't we do? We didn't do tan of theta. And tan of theta is opposite over adjacent, which will be y over x. If you check, your cast rule works then for tan too. Because in quadrant, for example, tan is positive in quadrant 3 according to your cast rule. In quadrant 3, both your x-coordinate and your y-coordinate would be negative.
Which means they may as well both be.
But a negative divided by a negative makes a positive answer. And big idea number 3 says that if tan of theta is y divided by x, and y is sine, and x is cos, it is always therefore going to be true that tan of theta is sine of theta divided by cos of theta. We can double check this, okay? Let's try to pick a really hard angle to confuse our calculator. Pi, let's do pi, sure. So I'm gonna try and write sine of pi, oh, for sure, oops, that's e, that's a different crazy number. Here we go, sine of pi divided by cos of pi. Get an answer. Disappointing. Wanted something amazing to happen here. Not that exciting of a number. And then we try tan of pi, and it is identical. Whatever angle you put in, tan of theta is always sine of theta divided by cos of theta. So from this simple idea of taking a circle, drawing a triangle in it with a reference angle, we get these 3 big ideas. Points on the unit circle are cos theta comma sine theta. We can then say the first major trig identity that sine squared theta plus cos squared theta is always equal to 1. And that tan of theta is always sine of theta over cos of theta. Also important is we are not content with just sine, cosine, and tangent. We are going to introduce to you 3 new ones. Cosecant, secant, and cotangent. Yes. And they are reciprocal functions. So, secant theta is the reciprocal of cos theta. Cosecant theta is the reciprocal of sine theta, and cotangent theta is the reciprocal of tangent theta, which also means, from our big idea, that if tangent is sine theta over cos theta, then cotangent will be the reciprocal cos theta over sine theta. And you'll have to memorize these definitions, and they'll be frustrating. Well, I think cotangent, being the reciprocal of tangent, has a hint. But unfortunately, the next hint that you might try to use does not work whatsoever. Cosecant does not go with cosine. Cosecant just goes with sine. And secant goes with cosine. Right? Why couldn't they, if this is cotangent, I guess maybe they tried. They probably started with, we'll call it cotangent. And then like, what should we do with the one with cosine? With sine? Oh, we'll call that cosine. Oh, we already have a cosine.
What if we call cosine cosine?
We could do cosine as cocosine. Yes. But then what would you do with sine? Maybe we would we could call this one cosine and this one cosine. Would that be confusing, but spell them the same? We do that in English all the time. Read and read.
And then we have cocosine.
Yeah, no, it'd be cosine, yeah. We should start a petition.
Why can't we just switch around it so it's closest?
Yeah, we just have a whole world we'd have to like
It would be
convince.
easier if they started
It would
with
be
the
way,
same letters.
yeah, the same letter ones would be way easier, but they went and messed it up.
Nothing easy.
I don't know how many years we'd have to go back in history and then just give that guy a slap or girl a slap, whoever it was. Come on! You don't know how much easier this is going to be for the rest of people for the rest of their life. But no, you're just gonna have to
It's
know.
supposed to be easy.
I mean, if we have a choice, we should make things as easy as possible.
Since when was math easy?
You're right. They're like, this is math, so we should make it as confusing as possible. Right. Question number 2. We are going to skip 2A for now and just do 2B.
To be or not to be.
Ooh, that is a good question. Determine the approximate values of the 6 trig ratios for 586 degrees. So they want us to do sine of 586 degrees, cos of 586 degrees, and tan of 586 degrees with our calculator. And also do the reciprocals. So cosecant goes with sine, secant goes with cosine, cotangent goes with tangent. And the first 3 with our calculator are really quite easy. We just have to do sine of 586, push enter, and we get the answer. Negative 0.719. Cos of 586 degrees, negative 0.695. Oh. I'm going too many decimal places, right? Says, no, I'm going just right. Yay, I am to the nearest 1,000. I thought I went too far. Yay. If a question does not say, they want you to round to 3 decimal places. This is what's expected on the exam, and they won't say, and then if you round to 2 decimal places, I think it's mean. They take off half a mark.
Is that one of the,
It's one of the round E6 is rounding errors.
Do they take off one per question or just in total?
On the exam, once the whole time.
it's
So if you
errors
hate
of
rounding, you can just like specifically round wrong in every single question and only lose half the mark on this. However, prior to that, to get you ready for that, if you do that 6 times on a quiz, I will take it off every single time so that hopefully you don't make that mistake.
Also, if you do rounding errors constantly, you'll often get the wrong answer.
Yes. But then they would still take that as a rounding error, not a mathematical error. And you can't lose a rounding error 6 times in the same question. So that much. And then tan of 586 degrees. 1.036.
It's time to make a light station to commit all the errors.
All right. So a couple things right away. Just looking at those answers, I know that 586 degrees is in quadrant 3. Can you see how the answers tell you that?
Yes.
Because tangent is positive and sine and cosine are negative. So the cast rule tells us it's in quadrant 3. You could also subtract 360 and say it's coterminal with, what would that be, 226 degrees? So then you'd say, oh, that's in quadrant 3 that way as well. Okay? Now, problem with our calculators is almost no scientific calculators have a cosecant button.
Mm-hmm.
Okay? What's the definition of cosecant theta? Is 1 over sine theta. So I would go and I would do 1 divided by sine of 586 and get my answer. Oh, I like this answer because you do have to write the 0 in to round correctly. And same thing, okay? One divided by cos of 586. 1 point, ooh, look at this rounding one. Negative 1.440. Really good rounding practice. And does it make sense that if tangent is positive, that when I do 1 over tangent, I get a positive answer still? 0.966. Here. Okay. I'll just write a note here. It seems obvious that that's what we do, but it's very important that when you go to cosecant or secant or cotangent and you're using the reciprocal, that your angle stays the same. Angles don't change. Well, we're going to do a bunch of different flipping in different places, and it's going to be enough to make your brain want to cheat and do things it shouldn't. So that could be coming up. Okay, so for this one, right now, the only question is 7.